is the digital infrastructure.
Yes.
DPI, digital public infrastructure. Nobody could believe that now even the people at the any level, they use UPI as if it existed for 100 years.
Yes.
That is the ease of use. You look at Aadhaar, I mean, we have 80 million transactions per day, and we have total authentication of 131 billion so far. I think it's mind boggling.
Yes.
And all that is with the privacy preservation. So we want to make very sure that India becomes a technology leader rather than technology follower. Interesting question, and you are not the first one to ask it.
Good evening, ladies and gentlemen. Welcome to a special episode of the ETCI Deep Talks Live, a learning platform where great minds share their perspective to educate, engage, and elevate the tech community, where we explore the frontiers of technology and innovation. From the moon's uncharted South Pole to the invisible frontiers of quantum computing, India is scripting a new saga of the scientific ambition. But behind every breakthrough lies a question. How does a nation of 1.4 billion balance cutting-edge innovation with the pressing needs of its people? And today we are in conversation with the man tasked with answering that very question, Professor Ajay Kumar Sood, the India's principal scientific advisor, a celebrated physicist turned policymaker. He is the architect of India's moonshot missions, from quantum supremacy to AI ethics and beyond. So welcome, Professor Sood.
Thank you.
So your role is often called the bridge between the science and society. But as we stand as the cusp of the technological revolution, I want to start with a bold question. Like, is India ready to lead the global scientific order? Or are we still playing the catch-ups?
Thank you for having me. What you have asked is a very important question. I think the answer can be given if we look at where are we at this stage of our journey to become a Viksit Bharat. So if you look at India's prowess in S&T, I will focus only on the S&T part. 3 examples will tell us that we are really moving very much up the ladder. One, you look at the biosector or the pharma sector. All of us have seen what India has done to mitigate when the COVID happened, what we did in vaccine, very, very fast development, almost in 8 to 9 months, we rolled it out. And all the population, the 99% of the population was vaccinated from India's manufactured vaccine. And we are also called pharma of the world. So that is one sector which will definitely tell us that we are doing something right. Second thing is space technologies. In space technologies, though we started relatively recently, about maybe 60 years back, but we have already come to a stage when we are doing Chandrayaan 3. When we did this, we landed on the South Pole. Then we have Aditya L1 mission to probe Sun. Then we have Gaganyaan mission, which is in the making. And a few days back, we had the docking of the in the space, which is again a very important technology, which many countries won't have and won't give you. Third one, which all of us are proud and we live 24/7, is the digital infrastructure.
Yes.
DPI, digital public infrastructure. Nobody could believe that now even the people at the any level, they use UPI as if it existed for 100 years.
Yes.
That is the ease of use. You look at Aadhaar, I mean, we have 80 million transactions per day, and we have total authentication of 131 billion so far. I think it's mind boggling. And all that is with the privacy preservation. So, what we have done in India, in our whole process, we have brought the government things where we developed the platform, but the APIs is with the private sector. If you look at the UPI, we have 10 players. This is the way to go about, and we have a techno legal mechanism to really take care of all these processes without human intervention. So you can see, and all these three recent examples tell us that India is not in a mood or to be a follower, but we definitely want to be a leader. So we want to make very sure that India becomes a technology leader rather than technology follower.
Absolutely, very interesting to know and very informative. So, like your journey spans groundbreaking research in physics to shaping India's science policy. So, how does a scientist's mindset navigate the complexities of governance?
Interesting question, and you are not the first one to ask it. Actually, recently I gave a talk which was my journey from Vigyan to Vigyan Bhavan, because we are in Vigyan Bhavan. So I encapsulated what it means to be a scientist, where we are looking at curiosity driven science, which can lead to innovation, then going to making science policies and implementing strategy. Policy is not enough. We also need a implementation strategy. So think of it. What does a scientist do? Scientists, they are meant to have original thinking. They look at the problem from first principles without biases, make hypotheses, do experimentation, and do validation. Same thing you can see is in the policy domain. Why do we need policies? We need policies because we want to make a scale change, not ad hoc change. That's why we need policies. Otherwise, things are happening already in one way or the other. We want scaling. Now, it means we need to analyze, if we want a policy, why do we want it? I'll give you an example as we go along. So, if you are open to this logical thinking, decision making ability of scientists based on the data, based on the evidence based answers, that's what you need. And that is what will make a very stable policy, and a policy which will not have too many after effects. You can always make a policy in an empirical way, but that will not be sustainable. If you want a sustainable policy which makes a long term impact, you need to think what all could go wrong and who are all the players. And science also tells us, be ready for criticism, because there could be a better solution. So that is what we all need in the policy domain as well. So we need policy for science, of course, but we also need science for policy. So this dual relationship is the one which will give us all the results. So we have looked at many of this, Prime Minister's Science, Technology and Innovation Advisory Council, which is under our office. We have rolled out in the last few years many missions which were conceptualized in PM Strike. But then all the framework is made, relevant ministries come on board, because they are the ones who will have to implement it. So we had quantum mission, which is rolled out. We have green hydrogen mission, national green hydrogen mission. We have many such things, AI mission, One Health mission. All these missions actually have huge policy component, but also how do you implement on ground? So it's not just you write down something and it will happen. No, you need to also see the framework. So, in that framework, what will work possibly, and you cannot import something from outside. The ideas, no. Ideas have to be seen for our system, for our constraints, for our resources. So, that is how I find a very interesting way that I could carry my scientific curiosity and technology development from my earlier life to this life, and the dialogue is on. It's not I learn every day actually, and that is what a scientist is supposed to do, learn from every example. So I have a feeling this decision making based on evidence is the way to go about, which is happening, which is also showing us the results in all these missions. And this is where you need to also bring a human angle, because you need to bring people along.
People along. We have to make the engagements. With the
So,
people.
wonderfully, we have the fantastic leadership who really is full driving us to take technology based solutions, but with a human touch. That's important. So, when we talk of AI, we need to talk of AI which is inclusive, which takes care of the society issues and so on. So, it is a holistic approach, and I don't think we will have a final document that this is the way to do, but it evolves with a given problem.
Very well said. Very well said. So, like, what you once said, like, science is curiosity and governance is compromise. So, has there been a moment where this challenge led to a surprising breakthrough?
Actually, there is no conflict here between curiosity and compromise, if you think of it. I'll give you one example, because example is the best way to demonstrate what is possible. Recently, India has rolled out one nation, one subscription, which means we have brought together the knowledge dissemination, the access to knowledge to a large number of people. All government, academic institutes, universities, state, center, everyone will be now having access to this. It's not easy. We will have almost 180 lakh users from this year, which was earlier 57 lakhs. We will have access to almost 13,400 journals, which is much, much more than what we were having. And we will have access, we will have institutes, almost 6,400 institutes will have access. Imagine these institutes, some of them who are in state mostly and all didn't have resources, will have full access to all journals, which means if you do physics, it is not that you only will have access to physics journal. You will have access even to social science. Interdisciplinarity, which is at the heart of national education policy. Anusandhan National Research Foundation. Now, this was a dream, correct? This is curiosity. We wanted to make it happen. Now, compromise comes, because your part is compromise. Where does compromise come? When we started, we said, oh, it will have access to everyone on the street. Anyone can have access. Good dream, but you realize that the cost will be enormous, because publishers will need enormous this thing. So that is why we have gone in a phase manner. So that's the compromise. We have taken now a large number of institutes, almost like 6,400. In the next phase, we'll bring whatever is left out, and maybe later on, anyone public can have access in the phase 3. So this is what I call compromise, which means you take reality into account and you make it happen. So I will say curiosity allows us to imagine a good future. and compromise makes it a reality. So, dream to reality is what you need to do, which is also true actually in our daily life. We compromise just to get the best out of it at a given situation, but keeping in mind where all we want to go so that you make the process. So, I think there are many examples. You need to think big, There is no question. As they say, low aim is a crime. Famous saying by President Kalam, low aim is a crime. So you shouldn't think low, think high. In the implementation strategy, see what you can achieve now rather than dreaming that, oh, the ultimate will happen somehow. No. Ultimate will happen when you make it happen through a path. And that path will have some compromises without losing the basic structure. So that's the whole idea of curiosity and compromise.
Absolutely. So very interesting, like very informative. So like when it comes to the quantum mission, like India's quantum mission aims for global leadership by 2031. But critics argue that we are late. So where's India's secret edge in the race when it comes to like startups, sensors or cryptography?
So I will not agree with the statement that we are late. Actually, we have launched a quantum mission last year, and it is really firing on all the four engines. Four engines means quantum computing, quantum communication, quantum sensors, and devices. Now, in very short time, which this is the mission which was conceptualized in Prime Minister's Science, Technology, Innovation Advisory Council. Lot of work happened, and Department of Science and Technology is the nodal agency to implement it along with other departments. So this is not this is a whole of India approach. Department of Space is part of it, Department of Atomic Energy, and other players are part of it. So other players will also be contributing to this, like MIT and DOT, they will also be contributing. So it is the whole of government approach which is doing it. And in some parts, we are lagging. I agree with you. In a physical quantum computer, we have a limited number of qubits, as you know. But to scale up is what the mission is. And good news is that the startups are along with the academic and national lab sector. So it's not isolated. So this mission has already rolled out 4 hubs already. They are in place as we speak. And in those 4 hubs, I was just looking at the numbers before this, we had 384 proposals which came to make these hubs. Can you believe? Which means there is so much of preparedness. And we have been able to fund right now, because we have to go in grades. We have formed 17 technical groups. Each technical group has many, many institutes. And total number of institutes which are involved is 43, distributed all over the country. So it's a spoke and hub approach. And 43 institutes have 152 researchers which are part of these 4 hubs. Which involves 17 states and 2 union territories. So what we have done is, it's not a single PI centric proposals. No. We want right from basic science to product, the complete cycle. And 8 startups have been funded already. And it will grow up now. So what I am trying to say, we are not in quantum hardware like quantum computing. But it doesn't mean we are not using quantum computers. You can always get on the cloud and do it the way we did our other computers. We didn't make the computers right from the beginning, but we use the computers to develop algorithms. That's how the software services came, where India made a mark. Y2K is a good example. We remember how it changed the world when they took note of India's prowess. So quantum computing has both aspects, quantum hardware and quantum algorithm. Now, good thing is quantum hardware, computing hardware is still evolving. You do not know which will win the race. Will it be the superconducting qubits which will win the race? But 2 days back, you heard another thing, topoconductor, topological superconductor is the new thing from Microsoft. That has come on the scene, that we are also a good player. But they have done right now 8 qubits. They will also scale up. So in this critical and emerging technology, we have to be a very strong player. Why? Because quantum security, quantum safety is a issue real now. All your cryptographic things right now, classical one, will be compromised when quantum computers become available, which are powerful and which have less noise. So all your financial transactions are going to be in problem. So that is why we need post-quantum cryptography, which means algorithms which will be quantum safe. We will need our own computers because our adversaries can store the data now and decipher later. So quantum technologies is not a choice, it is a must. Each country has to become independently secure. So quantum security is a big thing. And when the quantum computers become available, you will have all the optimization problem, traffic management in air, factories, traveling salesman problem in all fields will be handled and are being handled. Communication, quantum communication is a reality in India right now. We are way ahead of others, way ahead. We already made the quantum communication over 300 kilometers right now. Satellite based quantum communication is happening. So what I'm trying to say, quantum communication, we are quite way ahead, almost matching with the international scene. Quantum computing algorithms, we are proceeding. Hardware will take some more time. Quantum sensing, we are doing well. Very sensitive magnetometers to look at your brain signals and so on, and gravimeters, which means which can measure a change in the gravitational attraction of Earth, so that if there is a tunnel below this lab, you can detect by measuring a very, very small change in gravitational attraction. So whatever Newton said, apple falls because of gravity, it will fall differently when it is in different places. How different it is, because Earth is not solid. You can have a tunnel, you can have a well, you can have a water body, you can have minerals, you can have strategic importance things. That's where you need very sensitive gravimeter. That work is going on. So if I start telling on quantum, which is my weak spot, I will take hours. But point is, we are not behind, and we are actually on many of these things under mission. And DST along with the other players is taking it forward. And we have a governing board and we have an executive council, and all of us are involved to really make it happen.
Okay, very informative, no doubt. So like you mentioned, about the quantum communication satellite. So in recent reports, ISRO is testing a satellite-based quantum communications. So can you please highlight something about it?
So ISRO satellite will be launched soon, which will be based for quantum this thing. So you need, let's say, a dedicated satellite, and you can have ground stations, let's say 2000 kilometer away, for example. Now this, if you want to do with the fiber, it will be very tough, right? You will have to put many nodes, because right now We don't have quantum repeaters. So we will need every 150 kilometer a secure node. It's a huge affair, very, very complicated, which people are doing, by the way. We are also doing. We need another approach, the satellite based. And that is our target in quantum mission. We want to achieve this terrestrial two stations which are away 2000 kilometer on Earth, enabled by the satellite, quantum satellite, and it's quite a non-trivial thing, and that is the work going on. So ISRO is part of the quantum mission. I told you.
Yes.
I told you ISRO, DRDO, and DAE are part formally, and informally we have DOT, Department of Telecommunication, and MIT. All six actually are working on this, and ISRO is dedicated to this quantum satellite mission. So it is happening as we speak, actually. So already there is a lot of progress which has been done.
AI cloud revolutionized Indian healthcare, but potential bias in algorithms risks, excluding rural population as we are a pluralistic society. So how does your office ensure AI doesn't widen the divide?
Very, very important question, especially in the light of recent discussions, and our honorable Prime Minister really has given a good roadmap for all this
AI summit in
the
Paris.
Paris summit. He has actually said the last word, if you think about it. What are we saying? We are saying whatever we do, it should be inclusive. The data should not have any bias. It should have transparency, and models should be explainable. How that message came to you, through what data? We need that. Right now, that is not there. Now, in that, we would have to have AI regulation, if any, which will have, because all countries will have, but the regulation will be very nimble. So we have made a report. So MIT had made a committee. I chair it, that committee, and then we had the expert groups. So that report, which is called AI for balanced innovation, I forgot the exact title. That report actually looks at the issues which you are saying, and it has suggested the pathways and what are the regulations, if any, we need. Very nimble. That is actually for public consultation right now on MIT platform. So the last date is actually 28th February as we speak. So we are doing public consultation, and good news is some very good suggestions have already come in. Not only from government alone, private sector, foundations, and other players, which are adding to whatever the work we have done. So it's not that our word is the final one. We would like to see what is the best model. So we are saying our policy should be do no harm policy. 3 letters, do no harm. On that you have to evaluate, and you have to see all the players, the one who is developing, the one who is deploying, one who is using it. All the players have their responsibilities. This cannot be done by 1 or 2 people sitting on the desk. It cannot be done. So what we have proposed, where we have a lot of experience because of DPDP Act, we have proposed a techno-legal framework. Our Honorable Prime Minister also said exactly the same thing, and I am repeating what he said. The techno-legal approach in AI, in data governance, is the right way. Because India has shown through our UPI, through our all Aadhaar and so on, it's techno-legal.
Yes.
Why can't we do the same thing for AI? So the data flow becomes very smooth. And we can have global data framework now across the boundaries with this kind of a framework. So India can be in a very good position to lead this revolution. Because what is AI, if you think about it? It has 3 components. Compute, where you need to train the data and infer. Training is done by a data set which are reliable, unbiased, and without any wrong things. You don't need wrong information. And the third thing is applications. All three are needed, correct? Now, compute, we are building enormous resources now under this AI mission, which is which has been rolled out by MIT. Already there is a plan to put 18,000 GPU worth compute available to people who want it, be it academic sector, be it startups. Compute will be taken care so that we can develop our own either large language model or small language model. It need not be always large. You can make sector specific models. For health, you don't need 630 billion parameters. No, much less. You want to make a model, let's say in language X Hindi, you may not need 630 billion. So the point is you can make sector specific models which will do much less compute power and inferring also, and very quick inferring. And we have all learned that this recent disruption which has come in the last 1 month by DeepSeek and all, it is a large lesson for us. The lesson is innovation is the key. Don't have a rat race. Just because if somebody is investing $100 billion, you have to follow it. No. That is the strength of India, right? We always say frugal innovation.
Yes.
That's how we did in Chandrayaan. Right? So that's our approach in AI. So that's what we want to do in this mission. So this policy is already in public domain, and it has 7 verticals. One of the vertical is safety, what you mentioned. One of the vertical is also ethics and so on. And what we need to also do through this, I can say, we need to have a model which is based on our cultural heritage and languages.
Because we are a pluralistic society, and we have a different of like languages, people, their diversity in ethics. So according to that, we need.
So we can have models which can be trained on our heritage scriptures, Vedas, Upanishads, Arthashastra, Ayurvedic things, Achar Sanhitas, all those. Nobody will do. But once we do, we become a leader. So we are all saying that we need to make whatever we want, but also India centric, where India can take a lead. India can take a lead in our heritage. India can take a lead which are problem very specific to our villages. India can take a lead which is specific to our cities, not city in one country or the other. Our problems are our own. We need solutions. So we need agent-based AI. We need generative AI. All that we do. So what does it mean? We need R&D and we need translation of R&D. So it's a beautiful cycle where all players will be needed. So it's not that we will only use the available models. We should use with care so that the biases are not transmitted. But at the same time, we have to mitigate those biases. So that's the approach India is taking.
Okay. So like, should India fear AI being weaponized for surveillance given the rise of facial recognition tech?
No, it will not happen in India. See, the reason I'm saying is we are a democracy. So we can't take what other countries will be doing. Point is, if you use the data for security, for crime detection, this is what we do, let's say for crime detection, which will be very difficult to even proceed further. All that is right. So what it needs is weapon, if it is in the right hands. So you don't have to be scared that knife will cut you. Knife is a weapon. But knife, if used correctly, is your friend. Also, it can be misused. So, my point is we need to be agile. We need to see what are the boundaries. Of course, people are now worried whether AI can generate itself and consciousness and all, which are future things. I'm saying we are not looking at those problems right now. We need to see how we use AI to empower our citizens. That's the goal. That has a huge potential. Now, the what you said about surveillance and all, these are side issues which should be taken into account, and government is very conscious of it. And the existing laws are there that we should not take it for granted that you can misuse. There are laws. So it's not that we need new laws. So we need to be careful, but we should not be afraid that AI will do this, so hence we don't want to do it. So AI has to connect with society. AI should be sensitive to the concerns of the society, and at the same time make the economy to the next scale. So AI revolution is not here to stop. Let me say this.
This is the next big thing.
Next big thing happening in our lifetime. It will make a huge difference.
Yes.
We need to be a player with a front forward bat rather than backward. We need to do that.
So, like India is betting billions on semiconductor. Let's come to the semiconductor. So, India is betting billions on semiconductors, but we are yet to see a major fab. And is this about geopolitics, not just economics?
Actually, we already have now, as you know, sanctioned under India Semiconductor Mission. We already have one fab coming with Tata's, right? And already you know that India ISM invested 76,000 crore rupees. So there we have one fab already coming up very, very fast. And in that we will have ATMP, which is assembly, testing, marking and packaging, 4 of them already sanctioned. It will grow further. So we need to create the complete supply chain system. It's not just fab. There are huge number of chemicals, products, all these fabs will need. So it's not like one fab which will do everything. It's not like that. So what India has done is a absolutely remarkable decision to take this semiconductor thing, which is at the heart of all our technologies. All. Yes. Billions of dollars we import. So we need these fabs. One is already under construction, and it will come up in next few very soon. If you want India to be a product nation, which is what we want, that's what our Honorable Prime Minister has said. Product nation is our goal, not only the service. We are service economy to some extent. We need to bring the product economy. Now, what is product economy? Unless you make your own products. It's not the system assembly. No. System assembly is one aspect which we are doing a lot. As you know, we are assembling cell phones and with some Indian manufactured parts and all. But that has to go up. We need to design the chips. You know, world's largest population of designers is in India. But we design for others. So what I want is, and what government wants, and what Honorable Prime Minister has said, and what MIT is implementing, we need design capability. In that design capability, there has to be the following difference, which I want to bring out. Right now, we can design based on somebody's specification. No, I don't want that. I want to go one step beyond. We should be able to design our own specifications and then design. What does it mean? It means future thinking, that this is what world will need 2 years down the line, because everything takes 2-3 years to come to market. This is what we need. We need those and we have the think tanks. We have the brilliant minds. We need to enable them. So we need design conceived in India, made design, and then produced. And everything production we need not even do in India. Nobody is saying that. We need to bring the ecosystem. But we cannot be a player that we keep on importing the components. No, that is not even strategically correct. If you want strategic autonomy, we need these semiconductors.
Definitely. So I believe like by each and every passing day, the dream of semiconductor in India
is happening.
Is happening.
Is happening. And we will have the second phase soon.
Okay.
I'm sure it will be sooner than later. So phase 1 is already done.
Okay. It is always like said like rare earth minerals are critical for chips, and with China controlling majority of them. So is India semiconductor project will be affected by this China?
Yeah, see, what you are saying is right. I'm not saying that it is out of place. India has taken steps. India has woken up to that many years back. I don't know if you noticed this year's budget, which was announced a few days back, has a national critical mineral mission with a outlay of 34,300 crores in the next 7 years, and government has allocated 16,300 crore rupees earmarked. I think it is phenomenal. So that only tells you, and the remaining we think private sector will come in, which will come up. That's what I called implementation at scale. So critical minerals, we are all very sensitive. We all know how the supply chain can be affected, and measures are already being taken. In critical mineral, there is another important component is the recycling of the available products which become old and which go out of service. Enormous amount of critical minerals are there. And that technology has also been developed in India in many players. Okay. There are already companies now which are leading at world level. What I'm trying to say is we need to do all. Mining of fresh minerals, looking at the recycling, and also looking at the life of a whatever component we have is enhanced. So all approaches are needed, and we have taken very major steps, and critical mineral mission, which was announced few days back, is an example of that.
Very informative, sir. Thank you for sharing your exclusive insights. Let's come to the 5G and 6G the sector. So India has a 6G ambition targeting 10% of global patents, but the progress is apparently dismal. So your
Yeah, actually, the factual thing is that lot of the frequency spectrum for frequency bands for 6G by ITU are still being considered. It's not a closed chapter. And India, as you know, has two things which has done. The DOT. What they have done, they have made a Bharat 6G vision and mission that has been made, which will look at affordability, sustainability, and ubiquity of 6G technology. And another one which it has done is they have formed a Bharat 6G alliance of academia, industries, startups, and all the players and policymakers. These two things are really looking at it. So it's not a job of one player or the other player. It is a combined effort. That is what we did in 4G, 5G. The 4G, India is self-sufficient. Yes. Why? because we brought academia and industry together. We brought them together, and that's what made a difference. That's what we are trying to do in 5G and 6G. Now, what is important in this? It's a very competitive market, and people try to control the regulations. The what will be a standard. If you are not technologically high, you cannot contribute to making a standard. So India is now getting empowered, learning from 4G and 5G for 6G, that it is there. But what you are saying is right. We have to be on the watch, and we, under this Bharat 6G vision, we need to move forward. And there is already a consortium which has been formed.
So, like SATCOM is likely to be the new connectivity frontier in a few years from now. But do you think it's time for terrestrial operators to collaborate with them rather than worrying?
Absolutely. See, it is not one thing or the other. Both of them will coexist in any economy, be it India, be it any other country. So instead of worrying, we have to see the complementarity, because there could be regions which are unreachable by terrestrial network. That's where we will have SATCOM. We will have SATCOM in other strategic sectors. All that will be needed. So my feeling is that it is naive to say this is this or that. Both should be done and are being done. And we already have an example like the geo with the geospace, which is the SATCOM, and the other Bharat Airtel with One Web India. Already there are efforts. So I would call we need both, and that's the way to do it. So we don't have to shun away one or the other. Both will be coexisting.
Sir, like net zero by 2070 sounds distant, and 2017 is like very far. So, what's the one tech that could accelerate India's green transition, green hydrogen, nuclear, or something unexpected?
Actually, what happens is that looking at this question, we asked the same question 2 years back. So what we commissioned a study, scientific study, on looking at all energy options with us, be it coal, in a way that it does not add to carbon addition, nuclear, solar, wind, all renewable things, and whatever will green hydrogen. Sorry, I missed a very important thing. All that this report has considered, and this is there on our web, which is done by IIM Ahmedabad. In that you will see we have, with various scenarios, the mix of all, and it will not be one or the other. And in that you will see that nuclear plays a very important role. So as you know that nuclear, which can be available 24 hours instead of available only in daytime or in certain parts, that's what is happening. So nuclear, there is a stepped up effort, and in this particular budget you might have seen that government has announced 20,000 crore for toward this Bharat SMR, a small modular reactor. So that effort is on, designs are going on, and so on. So nuclear will be again very important part, along with all the other consideration. Green hydrogen, we are committed. The mission is almost 18,000 rupees crore rupees, 19,000 something crore. Our office has been playing a very significant role, along with the MNRE, which is the lead agency. And we have 5 million metric ton per annum production of green hydrogen. Of course, its applications and so on are also there, and we have a R&D part. So I will not say it is one or the other. All these efforts should be proceeding, and it's not that we are slow in that. So all are actually going on. Green hydrogen is in a very major way, which also will be supplemented by battery technologies and all those When you have solar, you will need batteries because you have to store them. All that is happening. Nuclear is one,
Yes.
and nuclear, there could be many, many more things happening.
Very interesting. So, very exclusive insights you have shared. So, your critic says nuclear energy is being ignored. So, is thorium the answer or a distraction?
Actually, it is not being ignored. Even Homi Bhabha, the father of nuclear energy program, envisages that it will be in 3 stages. And the fast breeder test reactor, which came up in Kalpakkam, and there is a plant being made based on that, actually is to take care of the thorium cycle. So thorium will be made into U-233, which will be further used. That was the whole idea, right? And that is happening. But now, even more efforts are happening on utilizing thorium. So, atomic energy, I'm sure they are the better people to answer it, but they are working on advanced heavy water reactor to utilize thorium. So, thorium is our future bet. But before that, even we will have this SMRs, we will have many, many more pressurized heavy water reactors and so on. All that is going on parallelly. So, nuclear energy is going to contribute towards our mission for achieving net zero carbon.
So, thank you for sharing your exclusive insights. Before we wrap up, let's take a break from this incredible discussion. Now, let's switch gears and have a little fun with the rapid fun fire segment. I'll ask a quick questions and you can answer in a word or sentence, whatever feels right. Okay, ready? Can we start?
Yeah.
So, tech you are most excited about in 2025? That one tech that you're excited.
Quantum technologies.
Quantum technologies.
It's here to stay, and it will make a difference in nations' technology prowess.
Yes, definitely. What is one sci-fi concept India should invest in?
Okay, one thing I can see, which is still uh, sci-fi maybe, but there are already thought, can we make a space elevator?
Space elevators.
What it means is, instead of going and doing the satellites and so on, idea is what you have in an elevator in a building. Make an elevator from Earth to space and take the elevator. Right?
Something like what Japan is working for.
Japan has even a startup to think about. But
Yes.
think of that. What does it need? The reason I am saying this is, earlier it was a science fiction. But now, with the discovery of carbon nanotubes, people think, aha, maybe this is possible. Why? Because if you use steel wires, by the sheer weight, the wires will sag, right, after a certain length. So, what you need is the strength by weight ratio to be very high. Weight should be small, strength should be high. And the only material on Earth which can satisfy this is carbon nanotubes, in which I have personal interest because I have worked a lot on that, where we discovered flow-induced voltage generation, Sood effect and all that. That's a side story. Carbon nanotubes have the right strength and they are very light. So carbon nanotube, just to give you a feel to the people, yield strength, tensile strength is 150 gigapascal. Steel has only 5 gigapascal. Even if you put all defects, everything, it will still be 50, 10 times better. And weight is very, very less compared to steel. So carbon nanotube ropes is a hope to realize this science fiction dream into reality. I don't know if it will happen in my lifetime, but maybe in some younger people lifetime it may happen.
Definitely, definitely. A policy decision you wish had moved faster.
I mean, one can always do a hindsight thing. There is no dearth of that. But I think this one nation, one subscription, I wish it had happened many years back. Because there is no reason it couldn't have happened. We need to bring the people together, negotiate with publishers and so on. And this is one thing which will really democratize the access to knowledge. And this is one, I'm very, very happy it has happened. Ministry of Education has played a humongous role. Many, many players are there. Science departments are there. I wish it had happened earlier.
One gadget or tech tool you can't live without?
Of course, now we are all slave to our smartphones. I don't know what the life will be if we don't have the smartphones on almost a minute to minute basis, which we should not use actually. This thing, but I'm just on jokes aside. Smartphones have made our life simpler. If you look UPI,
Yes.
UPI couldn't have happened without smartphones, right? I mean, I transfer money to you or to a vendor in less than 10 seconds. Actually, it's less than 10 seconds.
Yes.
So smartphones has become like a part of life.
And you don't even have to carry your cash.
I don't do that these days. So that's truly so. It's so wonderful. And it has happened in very, very short time. I don't know whether we should be thanking COVID, but it got amplified because of that. And our Honorable Prime Minister made it a policy decision. See, that's where you call disruptive policies. He gave this challenge. And this happened. Now even the credit cards are getting lost. I mean, thing of past. That's what we need. So that's where you need the leadership which can think of this and give a direction.
Regarding the UPI thing, the other big countries are also following India.
Yeah, yeah.
In fact, the France president,
Eiffel
Emmanuel
Tower.
Macron.
Yeah, wonderful. Absolutely.
Okay, one last question. AI or blockchain, what excites you more?
Actually, it is not this or the other. Both are good because blockchain is what? Distributed data. AI needs data. So both are excellent technology tools, vehicles, and I don't see them separate. Even blockchain will be integrated with AI or is integrated because distributed data sets also we can use. So I would not put this or that. And as I told, AI is really the flavor of the day because all these disruptions which we are hearing in the last 2 years have really made a impact even to the people who are probably not anywhere in science and so on. And it's not science, art, science, creativity, but we have to be careful. That's all.
So, Professor Sood, you have given us a master class in balancing ambition with reality. And thank you for decoding India's scientific future. From quantum labs to AI villages, India's scientific revolution is just a beginning. And stay curious and stay tuned. So, thank you. Any closing remark that you want to add, please?
No, I think what my feeling is science and technology should not be taken in isolation. Science and technology is a part of life because it tells you a way of life which has to integrate with all our other endeavors, be it arts, be it music, be it anything, painting, it has to integrate. So we should not say, I will do science and technology from 9 to 5. No, it's a part of life. So do that and also enjoy doing it. It should not be done as a job given. No, it should be our first take and take everyone along. If there are differences, science tells you be open. That's what science tells you. And be ready to change your views. We are all here for that.
Thank you, Professor Sood, for sharing your exclusive insight with us on our platform of ETCIO Deep Talks. And for more such episodes, keep watching ETCIO Deep Talks. Thank you.
Thank you very much. Pleasure.
Pleasure.